The Focke-Wulf FW-61 is a remarkable milestone in the history of aviation, recognized as the world's first practical, fully functional helicopter. Developed in Germany during the 1930s, the FW-61 not only represented a significant leap in aviation technology, but also laid the foundation for modern helicopter design. The aircraft's innovative engineering, coupled with its successful flight performances, made it a pioneering model that demonstrated the feasibility of rotary wing flight. This essay delves into the history, design, development, and impact of the FW-61, highlighting its significance in the broader context of aviation history. Historical context. Early experiments in vertical flight. The concept of vertical flight had fascinated engineers and inventors long before the advent of the FW-61. The idea of a machine that could take off and land vertically, without the need for a runway, was particularly appealing for its potential military and civilian applications. Early attempts at creating such machines date back to the late 19th and early 20th centuries, with various inventors exploring different mechanisms to achieve vertical lift. One of the earliest pioneers in this field was Paul Cornu, a French engineer who built a rudimentary helicopter in 1907. Although Cornu's machine managed to lift off the ground briefly, it was unstable and lacked the necessary control mechanisms for sustained flight. Similarly, other inventors like Igor Sikorsky in Russia and Emil Berliner in the United States also made attempts to develop rotary wing aircraft, but these early designs were largely unsuccessful. The role of World War I. The First World War, 1914 to 1918, accelerated technological advancements in aviation, but the focus remained primarily on fixed-wing aircraft. The challenges of rotary wing flight, such as maintaining stability, achieving sufficient lift, and controlling the aircraft, were complex and not fully understood at the time. However, the war did highlight the potential advantages of vertical takeoff and landing (VTOL) aircraft, particularly for reconnaissance, medical evacuation, and battlefield supply roles. After the war, several countries continued to explore rotary wing technology, albeit with limited success. It wasn't until the 1920s and 1930s that significant progress was made, thanks to the work of engineers like Juan de la Cierva, who developed the autogyro, a precursor to the helicopter that used an unpowered rotor for lift and a conventional engine for forward thrust. The autogyro demonstrated some of the principles of rotary wing flight but still fell short of true vertical takeoff and landing capabilities. Germany's aviation industry in the 1930s. During the 1930s, Germany's aviation industry was undergoing a period of rapid development. Under the Nazi regime, there was a renewed emphasis on advancing military technology, including aircraft design. The Treaty of Versailles, which had severely restricted German military aviation following World War I, was increasingly disregarded as the country rearmed and prepared for future conflicts. In this context, the development of rotary wing aircraft gained new importance. The German military saw the potential of helicopters for reconnaissance, artillery spotting, and transport roles, especially in difficult terrain where conventional aircraft might struggle. It was against this backdrop that the Focke-Wulf Company, under the leadership of engineer Heinrich Focke, embarked on the development of what would become the FW-61. Development of the FW-61. Heinrich Focke and the birth of the FW-61. Heinrich Focke, an accomplished aeronautical engineer and one of the co-founders of the Focke-Wulf Company, played a pivotal role in the creation of the FW-61. Focke had a deep interest in rotary wing flight, inspired by the work of Juan de la Cierva and others. However, he recognized the limitations of the autogyro and believed that a true helicopter, capable of vertical takeoff, sustained hover, and forward flight, was within reach. Focke's vision was to create a helicopter that could be controlled in all axes, pitch, roll, yaw, and vertical movement. To achieve this, he needed to overcome several engineering challenges, particularly in the areas of rotor design and control mechanisms. Focke's approach was methodical and innovative, combining theoretical research with practical experimentation. In 1933, Focke was ousted from Focke-Wulf by the company's management, but this setback turned out to be a blessing in disguise. He soon established a new company, Focke-Wulf, in partnership with Gerd Achilles, an experienced pilot and engineer. This new venture focused exclusively on the development of helicopters, with the FW-61 being its first major project. Design and engineering innovations. The FW-61 was a revolutionary aircraft in many ways, incorporating several design and engineering innovations that made it the first truly functional helicopter. The key elements of the FW-61's design included twin-rotor configuration. The FW-61 featured a twin-rotor design, with two counter-rotating rotors mounted on outriggers on either side of the fuselage. This configuration eliminated the need for a tail rotor to counteract the torque generated by a single main rotor, a problem that had plagued earlier helicopter designs. The counter-rotating rotors provided stability and allowed for precise control of the aircraft's movement. Rigid rotor blades. The rotor blades of the FW-61 were made of wood and had a relatively rigid structure compared to the flexible blades used in earlier designs. This rigidity improved the efficiency of the rotors and reduced the risk of blade deformation during flight. The blades were also equipped with adjustable pitch mechanisms, allowing the pilot to control the angle of attack and thus the amount of lift generated. Swash plate mechanism. One of the most important innovations in the FW-61 was the use of a swash plate to control the pitch of the rotor blades. The swash plate allowed the pilot to change the pitch of each blade individually as it rotated, enabling precise control of the aircraft's pitch, roll, and yaw. This mechanism was a significant advancement in helicopter control systems and is still used in modern helicopters today. Engine and transmission. The FW-61 was powered by a 160 horsepower Bramo SH-14A radial engine, which was mounted in the fuselage. The engine drove the rotors through a complex transmission system that included a central gearbox and drive shafts leading to the rotors. The transmission was designed to evenly distribute power to both rotors, ensuring smooth and balanced flight. Fuselage design. The fuselage of the FW-61 was relatively simple, based on the design of a conventional fixed-wing aircraft. The cockpit was located at the front of the fuselage, with the engine mounted behind it. The aircraft was equipped with a conventional landing gear, consisting of two main wheels and a tail wheel, which provided stability on the ground. Prototype testing and refinements. The first prototype of the FW-61, designated V1, was completed in 1936. Initial ground tests focused on assessing the functionality of the rotor system, transmission, and control mechanisms. These tests were followed by tethered flight trials, during which the aircraft was secured to the ground to prevent it from lifting off completely. These tethered tests allowed the engineers to fine-tune the controls and make adjustments to the rotor blades and engine settings. The first free flight of the FW-61 took place on June 26, 1936, with Gerd Achilles at the controls. The flight was a success, demonstrating the aircraft's ability to take off vertically, hover, and perform basic maneuvers. Over the following months, the prototype underwent further testing and refinement, with improvements made to the rotor blades, control systems, and engine performance. A second prototype, designated V2, was built in 1937. This version incorporated several improvements based on the lessons learned from the testing of the V1. The V2 featured a more powerful engine, refined rotor blades, and an improved control system. The V2 became the standard for subsequent flight tests and demonstrations. Achievements and records. First public demonstration. The FW-61's most famous public demonstration took place in 1938 at the Deutschlandhalle in Berlin, an indoor sports arena. This event was organized by the German Ministry of Aviation, Reichsluftfahrtministerium, to showcase the capabilities of the new helicopter to the public and to foreign observers. The demonstration was conducted by Hanna Reitsch, a well-known German test pilot and aviator, who would later become one of the most prominent female pilots in history. Reitsch flew the FW-61 inside the confines of the arena, performing a series of maneuvers including hovering, vertical climbs, and precision landings. The event was a spectacular success, attracting widespread attention and cementing the FW-61's reputation as a groundbreaking aircraft. The demonstration also highlighted the helicopter's potential for military and civilian applications, particularly in roles where conventional aircraft might be impractical. World records. The FW-61 set several world records during its flight tests, further establishing its credentials as the first practical helicopter. Some of the most notable records include altitude record. In 1937, the FW-61 set a new world record for altitude by reaching a height of 3,427 meters, 11,243 feet. This achievement demonstrated the helicopter's ability to operate at high altitudes, a critical factor for military reconnaissance and rescue missions. Endurance record. The FW-61 also set a record for endurance by remaining in the air for over 1 hour and 20 minutes during a single flight. This record highlighted the helicopter's potential for long-duration missions, such as search and rescue (OPER),